Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today as it is every day here in my virtual classroom. Okay, step on inside here. Now, in Integrated Math 3 material, we've been solving and factoring polynomials, equations and expressions and all that kind of stuff. And we are going to stick to some of those concepts here, but in graphing form. Now, I will link in the description section down below a video where I graphed out a factored form instead of standard form for polynomials, and I do mention a lot of things in there, a lot of useful things. I don't mention y-intercepts, and I'm going to be doing that in this video here, and I'm not saying I'm going to assume that you've done the things below here, but our goal is to get these things in factored form, and the things that I stated about factored form at the time will apply here, which mostly have to do with x-intercepts, multiplicities, the degree and leading coefficient of the polynomial, but we see those in standard form. But this video will go a little quicker as a result of some of the things that I'd covered there, even though it was a year ago. Some things that I covered there as well. So check that one out if you want to see more information, including turning points, local mins, local maxes. I'm not going to talk about that stuff here. I'm just going to say, how do we get a standard form polynomial, something that's a higher power than a quadratic, a cubic, quartic, quintic, etc. I don't know if I have any fifth power, probably third and fourth powers, and how we can then factor it down as we've done before and make sure that our solutions, our x-intercepts, are applied properly, the y-intercept as well, all that jazz. So I got 8 problems for us to do. I don't know if they're actually loaded up. Let's see. Black screen, white screen, there it is. And there are 8 problems for us to do. What I have is a graph for each problem here. I'll provide you a PDF of this thing, but a graph for each problem. I'll do the work down below, and then I'll go back up and graph it. 1, 2, 3, 4. And 5, 6, 7, 8. Yeah, it looks like the largest thing we have is a quartic. I don't want to go too deep into the fifth power. There's a lot to factor in those stages there. We could, but not in this case here. Okay, sketch the graph of each function on a separate sheet of, well, this is this sheet of a graph paper. I include all x, y intercepts right here. And that's basically the goal of this thing. So again, assuming that you've heard some of this stuff before in some way, or you'll probably pick up on it, the basic thing I want to cover is that when we have an odd degree polynomial, like a cubic, then your graph will either start down and finish up, or start up and finish down like so. It might have curves in between, it might not. When you have a fourth power, like a quartic like this, it'll either start up, finish up, or start down, finish down like so. One of the big things there. It'll start down, finish down if you have a negative leading coefficient, and it'll start up, finish down if you have a negative leading coefficient here. Otherwise, positives work out the way they do. Okay, our goal, guys, is to get the x-intercepts from this thing, and that comes from factoring. If we go ahead and factor f of x equals, right there, I have an x squared greatest common factor there, and inside I have x minus 3. And this is already factored form. I'm taken care of. The GCF was all that was in it. The x-intercepts are values of x when y equals 0. So when this equals 0, what x-intercepts do we have? Well, we got an x-intercept here of 0. We'll talk more about that one in a second. And an x-intercept here of 3. Now, the x-intercept of 0 has what's called a multiplicity of 2, which means when we cross through that 0 in particular, it's going to bounce off of the x-intercept. Instead of passing through it, it'll actually hit it and then come right off of it. Now, this is a cubic polynomial. It's a plus 0 constant. That means the y-intercept is also 0. When x is 0, y is 0. And that makes sense because when y is 0, x was 0. But we hit here at 0 and 3. At 0 and 3. But a positive cubic means it'll start from down below and then it will finish up here. Now, how do we, once again, start from down below and finish up and hit these 2 points? The 0 it's going to have to bounce off of in a quadratic sense like that. It'll bounce off of that one there, and then it's going to cross up through that 3 like that. I'm not trying to get all the points in between there, right? My goal is not to try and get all the relative maxes and mins and stuff like that. Somewhere it bottoms out right here. I can't guarantee where. Plus, the y isn't scaled. So, for all intents and purposes, guys, this is the graph right here. I could have made it a little better, I'm sure, but guys, that is the graph. And that's what we got there. I'll work with that. And that's number 1. That's it. You know, it probably goes a lot deeper down and all that kind of stuff. I could have been better about that. That's fine. Those are the features. Okay, number 2, and I have to move myself each time it looks like here. Negative x cubed plus 4x. It looks like there's also a GCF in play right here, as was the case for number 1. So in number 2, I can factor out and always factor out leading negatives, guys, as long as we're in standard form here. That's a big part of it. So negative x is factored out of here, and then you're left with x squared minus 4 inside. Now with that x squared minus 4 inside there, that can actually factor deeper into, that's the difference of 2 squares, right? So x minus 2 times x plus 2. So it's fully factored out now. We have 3 different x-intercepts that we can attack here. The first one is at x equals 0, like last time. What do you substitute for x here to get 0 out for y? 0 is one of them right there. 2 is one of them, and negative 2 is one of them. No multiplicities, nothing like that, but these are our 3 x-intercepts. Now there's a negative I want to talk about as well, and I really should have mentioned it right here, but the leading coefficient is a is a negative number. And you can tell right there, right? We didn't have to factor to tell that the leading coefficient here is a negative 1. This shows it right there, and that's one of the benefits of standard form. Factored form, listen, you can see it in factored form as well. It's no biggie. But standard form completely reveals this is a cubic and a negative 1 leading coefficient. And like I said, a plus 0 constant, it reveals once again that your y-intercept is 0, which is something that we get to run into a little more down the line. But it does hit a couple intercepts here at 0, negative 2, and positive 2. This one was a cubic. No multiplicities here, but it was a negative cubic, which means we start from the top. Starting from the top, meaning from the left side of this negative 2, it's going to come down into it from the top there. Start from the top, start up, and we are going to finish down right here as it passes through all these. There is no bounce off, bounce back, whatever you call it, with a 2 with a multiplicity of 2 because nothing was squared. Here, these were all to the first power, just like that. And that's our graph. That's our graph. I anticipate we're going to hit some y-intercepts shortly. Not yet, though. After this we will. So another 0 y-intercept here for the kill. X cubed minus x squared minus 6x. Once again, if there are things we can mention, the degree is 3. I'm going to probably start writing these. And the leading coefficient is a positive number, like so. It's a positive 1. So that means that it's going to start down, finish up, like so. Not this exact graph, but that's the idea of what we're going to see. That's what we expect. There is a common factor of x here, like there was last time. So if we factor that x out of here, we're left with x squared minus x minus 6, a quadratic which we can factor, and hopefully we've been very comfortable in doing so in the past. That is x minus 3 times x plus 2. So kind of very close to the last one, only it's a positive coefficient there, leading coefficient, and instead of a 2, it's a 3. So otherwise it's pretty close. We got a 0 there, so I'm going to graph this one relatively fast here. We are going to start from the bottom and finish upward here, having it be positive. So it's going to go through there. The y-intercept, once again, is 0. I did say mention x and y-intercepts. I'm just going to do that on the graph when they show up. But yes, the x-intercepts right there. Wait, what did I say? Did I say label? Include. So whether you write them or not is kind of your call, but that's x equals 0, x equals 3, and x equals negative 2. No multiplicities and such. The y-intercept has been 0 the last few times here. Y equals 0, I should say. Because if the x-intercept is 0, then so is y, right? And once again, this is a plus 0 constant there. And that's where it's going to be revealed, and I'll show you on number 4. So here we go, number 4. Let me move myself. There we go. All right, number 4, f of x equals x to the 4th minus 10x squared plus 9. I'm not going to graph the y-intercept yet, but we can get it right off the bat. I want to show you. If the x-intercepts that we're getting by setting y equal to 0 right there gets us, you factor it and you solve for x, y-intercepts are when you set x equal to 0. The y-intercept, you set x equal to 0, f of 0 equals 0 to the 4th, 0, minus 10 times 0 squared, 0, plus 9, and it's 9. You can see where the constant in standard form reveals the y-intercept. Somewhere it's crossing through some 9 right there. I'll label it after I draw the graph, but I'm just going to mention that that's a 9. Okay, and that's, once again, something you can do. You can do in factored form, but in standard form, it's right there. And in standard form, what else do we have? Degree 4 and a positive leading coefficient. So the degree is 4, and the leading coefficient is positive. Now it's our first degree 4, which means no matter how many roots there are, how many x-intercepts there are, it will, with a positive, it'll start up, finish up. It may wave in between, but it's going to start up and finish up right there, and that's what we expect. So let's go ahead and factor this one right here. This is f of x equals, and this is one of those quartics in quadratic form. If we break it down into an x squared deal like this, then we can get a little more out of it. Two numbers that multiply to 9 and add to negative 10 are negative 9 and negative 1. And no surprise here, we have some, we're trying to factor this, right? We're trying to find the intercepts. No surprise, we have some differences of 2 squares here. X minus 3x plus 3 for the x squared minus 9. Whoops. X minus 3x plus 3. And then x minus 1, x plus 1 for the difference of 2 squares on x squared minus 1. So like that. So our 4 x-intercepts that we have there are 3. I'm not going to write x equals, but 3, negative 3, 1, and negative 1. The y-intercept one more time is 9. I'll go ahead and label that after the fact. See, these graphs generally, the reason I don't have the y-axis scaled is these graphs can get extremely tall. They can get super tall, they can get super small, I guess, if you say that, tall in either direction. And here, we're going to stay within here for the x-intercepts, but y, it could go up to like 180, right? And I don't want to scale those for you, or at least pre-scale them. I'll let you do them on their own. You just want to make sure everything lines up properly. You know where it goes, whether it's factored form or standard form. So let's plot them at -3, -1, 1, and 3. This is a quartic. It will start up, finish up. So we should expect something where it kind of W's. It's going to come here and hit that, probably symmetrically, and then come back down and come back up, like so. Didn't quite hit those points, but I can pretend like I did. There, it's a little better. And then this is going to be 9. This is going to be y equals 9 right there. So we have the x-intercepts at -3, -1, 1, and 3. Very, very symmetrical, like I said. I assume it is symmetrical, at least. And then y equals 9 y-intercept right there. All right, first 4 are done. We only have 4 more and only 11 minutes in. Let's see what we can do. Although I imagine these are probably bigger. I can't remember when I made this. Okay, now we move on to... Oh, I remember how to fix this problem. Give me one sec. I think I had a negative factor out to begin with, so I think this is supposed to be a plus. Hold on, I have this somewhere. Give me 1 second. It'll be fixed on your sheet for yourself, for whatever you're doing here. Where do I have this sheet here? I have it right. Plus, yeah, so everything, I had factored out a negative at one point, so this is supposed to be a plus, and that's supposed to be a minus there. Let me find a way to do that. Let me kind of erase that and turn it into a minus. There we go. Factored out the negative, but didn't factor out the negative, if you know what I mean. Okay, so that's what the original problem is supposed to look like. This might not work if we have the problem like that otherwise. So here we go. X cubed plus 5x squared plus 2x minus 8. Let's go ahead and factor. So, listen, it's a cubic. You cannot factor by grouping here. And it's rational root theorem time, right? We have to look at our p's over q's here, factors of 8 over factors of 1. So p over q time, and that's going to be plus or minus 1, 2, 4, and 8. Once we find one, we'll go and use synthetic division on it, and then write the factorization from there. Hopefully the quadratic is then factorable. By the way, this is a cubic positive leading coefficient right here. So let's try some. Let's go f of 1. And that, I think that gives us 8 right off the bat. 1 plus 5 plus 2 minus 8, that's 0. So that one checks out. So let's go ahead and do synthetic division on that guy right there. 1 with 1, 5, 2, and negative 8. Okay. And that'll give us here 1, 1, 6, 1, 8. Oh. 6, 1, 8, 8, 0. And x that x-intercept, if you will, right? That's one of them. It gives you an x minus 1 factor. And then this is x squared plus 6x plus 8, like that. And that factors into x squared plus 2x plus 4. Excuse me, x plus 2 times x plus 4. X minus 1 times x plus 2 times x plus 4. That's the factorization there. So we got x-intercepts of 1, -2, and -4. And, you know, that's the hard part. Hard part's done. And then after that, we just graph. It's a cubic, so start down, finish up, and with a positive leading coefficient. So we start down, finish up like that. So we should just be hitting it like this the rest of the way. As far as y-intercept goes, look no further than your constant that we have here, which is a -8 right there. So that guy is -8. And then we have our graph there. So rational root theorem was used. I believe I use it for a couple of these ones down the line. I think that's how they were set up. And it looks like this next one kind of has to do the same thing here. So number 6, x to the 4th minus 2x cubed minus 3x squared plus 4x plus 4. Let's work our p's over q's one more time here. Factors of 4 over factors of 1. So 1, 2, and 4. I love it when it's just a 1. 1 minus, and it's not here. That looks like f of 1 is 4. Let's try f of -1. That's 1 minus, no, plus 2, which is 3. Minus 3, which is 0. Minus 4 plus 4. That does work. So f of -1 is 0. And synthetic division right here. 1, -2, -3, 4, 4. 1, -2, -3, 4, 4. 1, -2, -3, 4, 4. Okay, let's see how that one works out. 1, -1, -3, 3, 0, 0, 4, -4, 0. Okay, so this thing, ooh, goodness. So if you look at this one right here, this is going to factor into, remember, -1 was a root, so x plus 1 is a factor here. And then this is actually x cubed minus 3x squared plus 4. Not something that we factor the way we do with quadratics, and not a special case cubic either. So we have some more to do when it comes to this factorization here. Now, 1 didn't work before. So 1 is not going to work this time when we do this. It's possible that -1 is still a root of just this guy right here, which is something I still want to check on. Don't forget the one that can have multiplicities possibly. So I'm going to try that. And that's that's -1 minus 3 plus 4, which is 0. So there's another -1 that exists inside there for which I can use synthetic division to bring that about. And that with that 1, -3, 0, and 4, we're getting 1, -4, 4, and 0. So now this is factored into, kind of running out of room. Remember, there was a single x plus 1 to begin with, and then there's another x plus 1 that comes out there, and this is x squared minus 4x plus 4, which, by the way, is also a perfect squared trinomial, which is x minus 2 quantities squared. So this has a couple of perfect squared trinomials that factor down like so. X plus 1 quantity squared times x minus 2 quantity squared. That's the factored form. So the x-intercepts here are -1 with a multiplicity of 2. We already saw those ones, right? And then 2. We didn't see those ones yet. And 2 with a multiplicity of 2. That means that through these two things, it'll bounce off of those intercepts right there. This was a positive quartic, I believe it was. So -1 and 2. Let's plot those ones. -1 here, 2 here. Start from the top and cross through. And by the way, there's a 4 y-intercept right there. Right? The 4 is the y-intercept. So we're going to bounce off of this one like so. Probably hits 4 around there. I have no idea. And then bounces off again, and that's what we get. And there's that graph. It's all positive and a couple zeros right there. Okay, last two to do. -2x cubed plus 12x squared minus 24x plus 16. Let's check it out. -2 is a GCF right here. I'm going to start with that up here just because we might have to do some more work down below. And then we get x cubed minus 6x squared plus 12x minus 8, like that. So I cannot factor by grouping here, so I'm going to once again use rational root theorem here. Let's do our p's over q's and try those out. Factors of 8 over factors of 1, plus or minus 1, 2, 4, and 8. And just on the inside, start with 1. 1 minus 6 is, I think that's not going to work. Those are odd numbers. I think only even numbers will have to work, so let's try 2. 2 cubed is 8 minus 24 is -16. Plus 24 is 8 minus 8 is 0. So I believe 2 worked. F of 2 is 0 there. So synthetic division on that guy, 1, -6, 12, -8. 1, -6, 12, -8. Good news is after this we'll have a quadratic. So 1, -4, 4. We've seen that before. And 0. Remember, this was x squared minus 4x plus 4. So we know what that factors to as well. So there was an x minus 2 that factors out from this. And then this x squared minus 4x plus 4 factors into x minus... Oh, it's the same thing. X minus 2 quantity squared. So really, this is actually like... Oh, and there's a -2 on the outside. Sorry. And there's this is x minus 2 quantity cubed. So like that. That's the factorization of this. Now, the 2... doesn't affect anything for us on our graph unless we started in factored form and we were trying to find the y-intercept. We already know that the y-intercept here is going to be 16, so there's no effect on that. The only thing we really care about is the fact that it's negative right there. So this is a negative cubic, but it's not the same kind of cubic as before. There's only one x-intercept. The x-intercept right here is just 2, but it's got a multiplicity of 3. So it'll behave like a cubic going through there. It is a cubic. So going through there at 2, it's got a multiplicity of 3, and it's going to basically start from the top and go down because it's a negative leading coefficient. And it's going to have that cubic kind of appearance going down and through like that right there. That'll be good enough for me. And then this guy right here, believe it or not, that is a 16 right there. Not quite to scale the same way that the x's are, but I wanted to make sure to hit it. And that's what that graph is. The negative 2, the 2 is stretching it more. If it wasn't there, it would have just been an 8. And the negative flips that thing over. And that's the graph. It was a common cubic. Basic common cubic. Last one is number 8 right here, and then we'll be all done. We have negative x to the fourth. I'm going to factor out that negative. Negative x to the fourth minus 4x cubed minus 4x squared plus 1. Let's get that negative out of there. Negative x to the fourth plus 4x cubed plus 4x squared minus 1. And once again, no factoring by grouping. You know, there weren't as many different kind of problem types here as I would have liked. I would have liked some factoring by grouping problems and such. I'm sure we're going to run some of those in sum of two cubes and things like that. Problem with the sum of two cubes problem, you know, I don't know if we're going to run into those for graphing, because the problem with those ones is that you would have imaginary solutions, and those are hard to represent how the rest of the graph appears as a result of it. I don't think I want to play with those in the same vein. The graph is fine to do. I just don't think it's kind of worth its weight in gold as far as what we're trying to do with these polynomials. Anyway, rational root theorem has to work here. Now, we're only going to try 1 and negative 1, right? Those are our only p's over q's. Our p's over q's are plus or minus 1. Factors of 1 over 1. If you try 1, it's not going to work. You get 8. If you try negative 1, hopefully that thing works. We get 1 minus 4 plus 4 minus 1. That seems to work. So f of negative 1 is 0, and that is one of our roots. That's one of our x-intercepts, rather. So that was 1. Oh, and check this out. There's no linear term here. So this is going to be 1, 4, 4, 0, negative 1. That's 1x to the fourth plus 4x cubed plus 4x squared plus 0x minus 1 here. Let's see if we get that 0 remainder. Yeah. So now it became a cubic, so I guess more of the same. Still no factoring by grouping, sadly. But this is now, there's a negative on the outside. There's an x plus 1, and this is x cubed plus 3x squared plus x minus 1 right there. So we continue on with this guy here. Now, as I said, it's just 1 and negative 1 as your p's over q's. 1 didn't work last time, so it's not going to work this time. Negative 1's the only possibility. Does it work? We get negative 1 plus 3 minus 1 minus 1. It does work again. So we're going to do it again. Negative 1 on this guy one more time with 1, 3, 1, and negative 1, or at least one more time, because then we get down to a quadratic. And it gets down to x squared plus 2x minus 1, which in my view is not factorable. So there were 2x plus 1 factors there. That's going to have that multiplicity of 2. And then I have x squared plus 2x minus 1 right there. So that's not factorable there. I can tell you straight up off the bat it's not. So we got to solve that using quadratic formula or completing the square. I'm going to go by completing the square myself. We got to set this guy equal to 0. We're going to add 1 to both sides. And we're going to add something here that's going to complete the square. Divide by 2 and square it, you get 1. Hopefully you've done some of the completing the square stuff with me from before. This factors into x plus 1 quantity squared, and 1 plus 1, of course, is 2. Take the square root of both sides, and you get x plus 1 equals plus or minus root 2. Subtract 1, x is negative 1 plus or minus root 2. So, you know, I'm going to list out the roots that we have here. I'm not going to write out the official factored form from here. This is as factored as I'd like to make it, and we're writing out solutions. But they're rational solutions, right? So we've seen some. So what are the x-intercepts here? We have x-intercept of negative 1. It's got a multiplicity of 2. Let me just write mult of 2. And then we have negative 1 plus root 2 and negative 1 minus root 2. And I separate them because, you know, we got to actually plot these values. These are not imaginary, but they are irrational. And irrational means, you know, we should be able to find these on this graph, if you will. The square root of 2 is around 1.4. I think it's 1.42 or something. Let's see. Square root of, what is it? What are we talking about? 2. Square root of 2 is 1.414, blah, blah, blah. So what we're essentially graphing right here, negative 1 plus 1.4 is around 0.4. Right? That's what that number's about. That's what I'm going to plot on the graph. And negative 1 minus 1.4 is around negative 2.4. That's where those are going on the graph there. So when I plot these here, I got negative 1. Keep in mind the multiplicity, but I got negative 1 as a point. 0.4 and negative 2.4. like that. That's what those points are-ish. And we're not going to dive in with too many of those, but there's one set of them, and I think that's still worth noting because we can still graph it. So it's negative. There is a y-intercept of 1, which we'll just cross through eventually, but a negative quartic. So negative quartic starts down, finishes down, and it will bounce off at that negative 1 right here. So these are about the same distance apart. There's symmetry pretty much around the negative 1, I believe. So it's going to basically hit off like that, bounce off, and come around and back down here. And that's a good enough appearance of this graph here. There is a y-intercept here at positive 1 for that guy right there as well. And that's the appearance. That's it. Okay, guys, so that ought to do it for this one. Like I said, I would have loved a factoring by grouping problem. That would have been nice, but you dove in a couple quadratics, some perfect square trinomials, had a 1 cubic and bounce-offs and things like that. So I hope that some of that stuff made sense. If it didn't, check out the factoring video from down below where you, factored form graphing video from down below where you can see some more information on that. More unique types because we got to get ones that factor the right way from here without always doing rational root theorem. Like I said, I wish I did a factor by grouping one. But that'll do it for this one, guys. This is Mr. Robinson. Thank you so much for watching. Take care, and I will see you in the next one.